Alright, so we have provided with introduction for the recurrent neural net already. Then next, let's have a look at how to use the recurrent neural net to do some concrete application problems. So we can take the two tasks to be started in the stage 4 of your project as an example to illustrate how to build a recurrent neural net to start them. So if you take a look at the project description for the stage 4, you are required to build a recurrent neural net to classify the documents, right? And you can have a look at the dataset we provide you. We provide you with this IMDb, the review datasets. So inside the dataset, we have both training set as well as testing set. So for the training set and testing set, they are classified in both positive and negative instances, right? And each one will be represented as a document. So this document will contain several sentences, and each one also contains several words, right? So you are required to build a recurrent neural net to classify this document into either positive or negative instances in the task. Besides the document classification, we also have a task on generation of some documents, right? And if you take a look at the text generation data set, the data we have is about some jokes, right? Each joke is represented as one sentence. It contains several words, right? And we may require you to build a recurrent neural net to generate this joke based on the 3 given tokens in the very beginning, right? So let's have a look at how to build the recurrent neural net to do both the classification of the documents as well as generation of the documents. So based on document inputs, we can represent documents as a sequence of words, right? So in this page, we'll show you a potential architecture of this recurrent neural net when built to classify the documents. So given the document, we can represent the inputs all the words in the document as a sequence of words, W1 until Wn. Right? And what is n here? This n denoting the max length of the document. If for some documents which is shorter than n, for example as shown here, then we can add in some dummy paddings for the shorter documents, right? So here we can assume we have n inputs like w1, wn, and each one is represented as a word. According to the previous discussion, we can represent each word as its one hot coding or its corresponding ID, right, for the word. So now here, if we use one hot coding, each one will be represented as one vector, one hot coding vector input, right? And we can build one recurrent neural net with one single hidden layer as shown here, with this hidden layer shown here, right? And each hidden layer, they are connected with each other. So the representation will then for each of the hidden neurons as shown here, they will be serving as input for the following hidden neuron as well, right? Now from H1 to H2, from H6 to H7 as shown here. So for the hidden neuron corresponding to the last input, like Wn, and we can write its representation as Hn as shown here, right? So we know that Hn can serve as the input for learning the label of the whole document. In other words, we'll give serving this Hn as input for the output neuron, so we can calculate the corresponding label for the whole document as y. This y will be equal to W times Hn plus bias term, right? In this way, we can learn a label for the whole document based on the inputs of a sequence of words. So in this part, we only need to serving the last neuron, hidden neuron as the input for the output layer. The main reason is because this Hn, they will receive the information from all the previous neurons, hidden neurons, right? So each of them, they can capture the information from the input of these words to learn the representation for the last hidden neuron, right? Like this one. That's the reason why we only need to feed this last neuron, hidden neuron as input to learn its label. This is one way we can build this recurrent neural net. Someone may consider, if we just feed this Hn as input, because some of this information we have in the very beginning of the recurrent neural net, they probably will be lost when we calculate this Hn, right? The main reason is because when the chain is very long, then the information we can capture from the beginning part into this Hn will be very limited. Then another potential architecture you can apply for classify the documents will be something like this, right? We still have this input from W1 to Wn and denoting the max length of the document. So for short document, we can add some dummy paddings into it, right? So furthermore, besides the input layers, we also have the hidden layers, right, as shown here. However, here the main difference compared with the previous page mainly relies in the output neuron calculation. Before we mentioned that we can just calculate the output layer or neuron based on the hidden representation of the last hidden neuron, right? However, here we try to integrate all the hidden neurons together to calculate the final output neuron, this representation, or this y label vector, right? So by integrating all the hidden neuron representation together, we can sum them together to calculate the final label output is y. So compared with the previous ones, this kind of architecture will be, can capture all the information from the input in determining the output labels. So for documents which are very known, then all the hidden neurons we have in this architecture will play a very similar role in determining or deciding the final label, right? So for the words in the very beginning, the information will be effectively captured in the label vector, right? When we calculate this label vector, they will all have a role in the summation, right? So compared with this one, if we have non-document, then the beginning part of the information will probably be lost. Because if this chain is very long, more than 100 words, then the information we can preserve from the beginning part into this HN at the end will be very limited. So for the project, you can compare these two architecture to see which one works better, and for the project, and you can also compare the performance as well, because the implementation difference between these two architectures is very limited. The main difference lies in how to calculate the output layer, right? This is why you can either use the equation or you can use the equation as shown in this page to decide how to calculate this Y vector. Okay, this is how to do the classification of the document. Besides this one, you also require to build a recurrent neural net to generate some of the documents as well, right? So in this page, we can share with some basic information how to do the text generation based on recurrent neural nets. Now here we show you with the example like the piece of joke, like what did the bartender say to the jumper cables? You better not try to say anything. So if we plan to build a recurrent neural net which can generate this kind of piece of document out, then we can build this architecture as shown in this page. So according to the project requirements, you will be provided with 3 word inputs, right? And then you will have to build a model which can generate the whole piece of document or the whole piece of a joke out. Here, the main difference compared with the previous one, the previous one we can have a very long recurrent neural net. However, when we do the generation of the documents, we only provide with 3 token or 3 word inputs. Then we try to generate the whole piece of documents, right? So actually, when we do the generation of the whole piece of joke, the model architecture we have will be something like this. We have 3 inputs, and we try to predict the 4th word out. So here we only need to have 3 inputs. The architecture is very short. We only have 3 inputs and 3 hidden neurons. So based on the 3rd hidden neuron, we can further predict the word after the inputs, right? So we have the 3 first words inputs, then we can predict the next one, which will be the 4th word as the output. So according to the prediction result compared with the ground truth like bartender, we can calculate loss for learning this architecture, right? So based on the first 3 words, we can predict the 4th word. Then you may wonder, how can we predict the 5th word? The way we predict the 5th word is to shift the inputs to the right hand side. Here we have the first 3 words. What did there, right? And if we plan to predict the 5th word and based on the prediction of the 1st word already, we have this one already, then we can feed this did the and y1 denoting the prediction of the 4th word by the model, right? And feed them as the inputs to the model, then we can further predict the next one, the next word, the y2 as shown here, which will be the 5th word. And the prediction of the remaining of the word will be in a very similar way. Based on the previous prediction, we can further shift the inputs slightly to the right hand side. Then we can have the y1, y2. The y1 and y2 are the prediction from the previous steps, right? We feed them as the inputs for prediction of the 6th word, like y3 as shown here. So you can see when we do the prediction or the generation of the document, we have the 3 words as inputs. Then we can predict the following ones, right? And based on the prediction of the following one, we can further predict the words after that, and so forth. In this way, we can predict the whole piece of this sentence out. So this is the way we can do the prediction or the generation of this document. And you may also wonder when we should stop this prediction or the generation process. We will stop until we can reach the end of the sentence. So for each of the piece of the sentence, we will do the generation. We can manually add 1 end token, which is denoting the end for the prediction process or generation process. Once the prediction is the end token, then we can stop this process or the generation process for the model. So for each of the prediction, we can calculate the loss term. Then we can sum them together to define the loss term for the piece of this text generation, right? For learning the model. So you can see for the generation process, we only have to build a very small architecture with a few number of inputs and also a few number of hidden neurons as shown here. Then we can predict the next word and sequentially, right? And we can also shift the inputs, and based on the prediction from the previous step, we can further predict the next word sequentially, right? In this way. So this is one way we can build the recurrent neural for the text generation. Someone may also wonder, can we only build the architecture in this way? Can we have any other options or not? The answer is yes, we can also build the recurrent neural net for text generation in some other ways. In this page, we show you two other potential ways for building the recurrent neural net for generation of a piece of document. So the first one is very similar to the previous one. We are still predicting the next word based on 3 inputs, right? However, the main difference here lies in the output. So given the 3-word input, what we are generating as the output here actually are the next word for the inputs. According to the piece of joke, what did the bartender say, right? So the first word is what, and its following word will be the did, right? And we can generate one prediction for this next word for what. And similar for did, the next word will be the, right? Corresponding to this one. And the next word will be y1 or bartender, we plan to predict. So if we build the recurrent neural in this way, given 3 inputs, we can predict the corresponding outputs or the following word for the inputs, and we can define loss function by calculating the loss term for all these neuron outputs, right? So not only for the first word, we can also calculate the loss term for the did and the compared with the prediction results as well to define loss function. Compared with this previous one, this model architecture will be more robust. The main reason is because we can force the model can generate the next word, for each of the neural inputs, right? So you may wonder, can we only predict one single next word given the input or not? Can we predict multiple outputs at the same time? The answer is yes. If you plan to predict multiple outputs at the same time, then you can build a recurrent neural net in this way. Given the 3 input neuron, given the 3 input words, now what did the, what we can predict here is the 4th word, 5th word, and the 6th word together, right? And we can build a recurrent neural net in this way. Given the 3 inputs, we can predict the following 3 words as output. Then we can build a recurrent neural net in this way, and we also have to define loss function by comparing the prediction result compared with the ground truth, the 4th, 5th word, and the 6th word to define loss function. So compared with the previous one, this model architecture can predict multiple outputs simultaneously. So based on prediction in this step, then we can further fit the 3 predictions as input for the model, and we can further predict the following 3 words as well, right? And in a sequential way. So in this way, we can predict this document in a much faster way compared with the previous one. However, this one will also have a larger loss. The main reason is, we have to predict 3 words simultaneously. Based on 3 inputs, right? This mapping will be harder to learn compared with the previous ones. So for the project, you can compare with different architecture and to choose which one you prefer to use. For the classification, you can either try this one or try this architecture for the project. As for generation, you can do in this way or do in this way or do in this way. You can decide which one works better for your project. And you can also compare with their performance with each other to see which one works better. Okay, so this is how to use this recurrent neural net to do the stage 4 for the project, and you can try to play with them by yourself after class.